Okay, class, so we have to have our heads wrapped around this idea that circular motion can also result from the sine curve. But let's first talk about it in terms of just its curve. This is something called the general sinusoid. And even so, I've left out a portion that can usually go with x. It's going to have something to do with the horizontal motion. I'm just going to focus on these three pieces, these three modifications to the general sine function. There's this a value in the front, it's multiplying by the whole function. There's this b value that multiplies just by the x, that's why I put it inside parentheses. You won't always find it inside parentheses. Most of the time it will just say bx, and you've got to understand that it's only affecting the x inside the sine function. And then there's a plus c that goes on the end. So I'm going to go to my general sinusoid. It looks like this, and I graphed it on a window of radians. That also we're moving, so we've got to get more radian ideas and less out of the degree functions. This is in 2 pi radians. That's showing us one full cycle. Now if you relate that to a circle, that means you've gone one full circle all the way around. So this is showing that the maximum height was reached. This would be a value at pi over 2 or 90 degrees. This is at 180 degrees or pi. This minimum occurs at 3 pi over 2, and this is back at 2 pi. This height depends upon the radius of your circle. On the original sine function, where I just have y equals sine of theta, this r value is understood to be one unit circle. So it would reach a maximum value of 1 and a minimum value of the -1 at the appropriate places. So what we're going to do is figure out what these modifications do. And there's a great lab that goes along with this. Make sure you check out the resources section and use your Inspire to do that. But let's recap what those do. This a value in front, the multiplier, that relates directly to the radius of your circle. If you remember, we started off with a function that looked like y equals radius times sine of theta. That r value was the multiplier in front of theta, of sine. This a value is that multiplier here. So that a value is going to affect how high and how low the sine curve goes. In science class, we call that the amplitude because we're dealing with waves. Waves have amplitude, frequency, and period, all of which we're going to address in math class now. So this right here is your amplitude, which is the same as r. And if you go ahead and double the amplitude, or double a, 2 times sine of theta, it would result in twice the height and twice the minimum height. So you're changing the amplitude. That should make sense if you consider yourself being on a circle that would have twice the radius as well. You would have to go twice as high in the rotation. Notice it does not affect, though, the width of the rotation. We still will be able to fit a full circle in 2 pi radians, or a full cycle in 2 pi radians as well. So a is affecting amplitude. It's the vertical stretch. The next thing I want to talk about actually is this one. I know it's out of order, going on to C and not on to B, but C is the next easier portion. It's the piece that gets added on to the end, adding a constant. Well, adding a constant actually will shift an entire graph vertically. If that constant was negative, it would be a downward shift. If it was positive, it would be an upward shift. And so here I've drawn it as a positive shift or translation upward. So this plus c is changing something I like to call the y displacement, all right, or vertical displacement. Well, the reason we call it that too is it relates so well in the science class. When you displace a spring or displace a pendulum or cause a wave or displacing water, all of those change the displacement values. Here the y displacement is a change in y. We used to have y here at 0, and that would be our midline at 0. Now our y displacement has moved the whole midline upwards. And that's a word I'll use often too in class. This is the midline. All right, so the midline has been moved up to match this. So we have the 2 modifications so far. A was the radius and your amplitude. This C was your y displacement. Also your midline. But then that leaves B. Perhaps the more complicated of the features. Here we see an effect of B. By changing B, the multiplier in front of the x, you can change the number of waves you see. And this one actually would be written as something that looks like y equals sine of 2x. We see twice as many waves in this same 2 pi domain. Twice as many waves in the same cycle. If you imagine going around a circle, that means I can go around the circle 2 full times when I used to be only go around one time. So it's 2 full times in that same amount of space. So this 2 right here is the multiplier. But 2 also relates to 2 very important terms. One is the period of the function, and one is the frequency of that function. Now, period is denoted as the amount of radians it takes for the cycle to repeat, or the amount of time something takes before it to repeat. So here on the black one, the original function, it takes a full 2 pi radians to do a cycle on the sine curve. On this function, where it's twice the angle, or 2 times x, we can now fit 2 full cycles in, which means it completes a period in half of the space. Here's the idea. If I split this down here, I can now do this full cycle in blue in half the amount of space I used to be able to do it in. So the used to be able to do it in is the 2 pi space. So the new period would be half of that 2 pi. So the period of the function with 2 on here would be 2 pi over 2. If I could fit 3 full waves in the same 2 pi space, this number would change to a 3, and then the period of that function would be 2 pi over 3. So if I use this idea as b as a multiplier, the period would be able to fit, we'd be able to put the period in by fitting in b number of waves. That means I've split this 2 pi into b equal spaces that I put a wave into. So the period of this function would be 2 pi over b. Now the word frequency, the frequency is referring to the amount of waves you see in a set amount of space, be it time, be it angle, whatever you want to go with. So frequency is actually the number of waves we see in the same space. Here, frequency reference the amount of waves, 1 full wave in the black one for the 2 pi space, or for the blue curve, 2 full waves in the same 2 pi space. So it ends up being the reciprocal. I fit this many waves that I see over 2 pi being the interval we're working with. So based on this curve and this function rule, period and frequency both come out of this. One more thing, b has a given name. Okay? B is often referred to as the angular velocity. And that angular velocity is measured in radians per unit of time. Okay? Now there's a thought for you, radians per unit of time. Previously, this was an angle measure, x, but now we can reference it as a unit of time. Okay, tune into the next video and we'll talk more about how x turns into time.